So I guess we are live. Hey everyone, thank you. Hey everyone, welcome to day 7 of building a production rack system that supports 85,000 documents, NASA documents. Uh, this is day 7, and we, yeah. So the folks who are new, I'm just gonna quickly go through the progress. First of all, what we're building, what we've done so far, and then the progress we've made, and what we're gonna do today. And yeah, today we're basically gonna work on document processing. So not, I mean, the entire pipeline and everything is done. I'll go through them, but today we're gonna process 10,000 documents. I'm gonna use, we're gonna build, yeah, all the infra for it, like processing in a VLM, running the GPUs, managing memory, using VLLM, caching, and etc., and all of those memory related stuff. So it'll be an interesting stream, and I think it'll be split into two. For the first 3 or 4 hours, will be one part, and then I'll come back after I go out and do another stream today. Yeah, so I think we can kick that off today. Uh, cool. So first of all, before when I show you the progress we made, we'll just go through the stuff we are working on. So essentially, we're working on a RAG system for a fictional company called Meridian Aerospace. They're a consulting company that actually provides technical analysis and certification, something related to a lot of rocket stuff, right? And they deal with a lot of documents. In fact, they lead with a, oops, that's actually this. Yeah, whatever. So basically, what we're trying to do is that we're trying to build a system that can access their archive of documents. They have about 85,000 documents, and those documents are very complex, from scanned copies to handwritten notes to faxed copies, photocopied ones, rescanned ones, stuff duplicated rescans from 1950s to 1990s, 2000 and 3000. They have a lot of domain acronyms. For example, they have stuff like LOX, ISP, and so much more, where a lot of jargons where if you were to use an agent to search the query of a user, it wouldn't actually do it, and it needs to access all the domain acronyms and etc. So our goal is to my goal was to fine tune a model, but we're actually using two splits. One for the entire document processing, we are using everything is open source model, so in case the company is actually most of the time dealing with a lot of ITAR requirements, so I guess you call it ITAR requirements. So you could deploy this on-prem. No sensitive information leaves out. You'll probably most of the time have a system that is 100% compliant with their servers. Their cloud servers, they have government servers, or maybe even the on-prem servers. It should work as long as they have a GPU. And that's what we're going to tackle today. We've solved the document processing. Now we're going to solve it at scale. So for 10,000 documents, how do you do it? Sort of like a thing. Managing quadrant, the tokens and etc. The embedding space and etc. So mathematical equations, yeah, they have a lot of mathematical equations. In fact, I'll just show you quickly so you get a sense of because if I were to show it to you, you can visually understand the level of complexity this stuff goes to, this stuff consists of. So I'll take one PDF over here, and this is from the 1954. So you can see a ton of formulas, symbols, latex, and diagrams and whatnot. Okay, so this is one, and they also have a lot of others. So this is from 1963, and this is quite a clean PDF. There's very simple tables and etc. This is very clean, to be honest, even though it's from 1950s or 60s. And you have stuff like this which is so complex, where you have tables spanning across, continued across multiple pages, and then you have images like this and etc. So for the past 3 to 4 streams, I think 3 streams, we spent 30, I guess easily the stream will be like 30 hours or something like that. We spent 30 40 hours working on this, trying to work, trying to take so it's like this. We're going to solve for 85,000 docs. At hand, I have about 10,700 documents or something in my VM. I ran it overnight, downloaded from NASA RT NTRS. You can also download it. There's an API for it. Just search for NTRS, and they provide all of them for free. They have a limit on API requests, but you can manage the API requests and you run it overnight. I guess in 7 hours, I was able to download about 10,000 or more than 10,000 docs. We're going to solve for 8,500, and I've pulled up a bunch of documents that represents certain documents. For example, you have 1,000 documents from 1960s with tables and etc. So I pulled about 3 to 4, so I can visually see 3 to 4, like a random sample of it, like get a sample of that and visually solve for a diverse set of data sets, because I can't look at all 10,000, but what I can do is that get a sample of 1960s, a sample of tables, samples of physical diagrams, and then I could go ahead and sort of solve for that, and hopefully that will also solve the other one, the rest of the other documents that is sampled out. So yeah, very what called very diverse set of documents. Some of them are clean, some of them are not clean, and some of them are like super crap, to be honest. For example, this document, you can see like you can't make sense of anything with this image. This for me looks like an oil painting, but this is actually some photo of a crack in unit 507 LOX, cover sheet 10x magnification. So I mean, you can't make sense of it. But what we're doing is that we're saving all the figuring out all the images, formulas, and etc., tables and etc., and we're converting those to markdowns and keeping them, and also going to be we'll also be showing this to the user, right? So I'm going to quickly show you what we've done so far. So we built the initial agent, and I would highly recommend you to go through the agent, which is, I think, which is the last two streams. So the stream day 5 and 6 was that. What we did is that we spent hours. First of all, we didn't just directly jump into coding. We didn't jump into development. We basically understood the brains of the system, like brains of the users. What's their domain? What's their day-to-day life like? What are the jargons they use? What is the current systems they use? What are the queries they run? What are the traditional systems they use? How do they think? What is their problem solving style like? And also we basically formed the quite a good understanding, and then we jumped into code, and we actually jumped in and actually uh, you know, uh, like design the prompts and tools and the entire flow. I mean, it's simple. It's just a prompt and tool, but it's not that the case. You have to spike up the domain intuitions of the model, like a person like a senior aerospace engineer will actually solve the problem. So those domain level nuances would be something that comes in your system prompt. So we just it was like a 11-hour live stream. Just I would encourage you to go and check it out. It's very worth it. I'll skim through things. I don't have chapters yet. I'll create the chapters for them, and I'll leave it there so you can watch it when you have time. Cool. So we have the tools and etc. So let's go ahead and actually fire a very small question so we get a feel of what's really going on. So this is my question. Uh, Looks like a very big question. Yeah, I'm trying to validate the performance coding against the methodology in the report. Need to verify the exact equations. So basically, we generated this from Gemini. We gave access to Gemini all the documents we have, and all the specific document chunk we had, and then we asked it to uh, generate the use case. Now the thing is, Gemini could see all the 500 or 400 chunks, and this model will only be able to pick the right 400. So it's like finding that needle in the haystack sort of thing. Same thing we're gonna do. In general, even if you have 10,000 documents, you just have to find the right 40. And what we do is that we give all the 40 to Gemini. So Gemini could load the entire 40 and ask questions, but our agent would not have the 40, right? They could not have, so he has to pick that 40 among 10,000. That's how we're going to validate the system as well. Yeah, I think yeah, it did some decent work. So you can see it fired off a parallel research. This is like a hit and get sort of signal sort of research where it can run like 4 or 20 or 50 whatever queries. You have document info, adjacent chunks is basically like trying to read through specific sections. Like if you have find the paragraphs, go a little bit above, a little bit below sort of thing. And then visual region is where you want to verify like formulas and etc. You take a screenshot of the PDF and it can visually verify it. Get section would actually because we're using docking, we get access to all of the, for example, tree of hierarchy of sections. Let's say you drop in a document and then get access to all the hierarchy, so you can just search for this method of calculations, and then whatever paragraphs or section is underneath, you'll get it. So yeah, it's very simple, guys. I mean, of course, I don't want to spend much time into it because we've spent a lot on the last few streams. But yeah, you can see the final answer. There's a lot of latex. It's you can see them clearly, and you also have sources. If I were to click on the sources, you can see the sources that we are showing. Now, I was actually working on this. It had a bit of errors in the UI. Will come back to this later, and this is not a big issue to solve now. And yeah, if you do the tables and etc. And on the right, you can see show notes. This is the agent's notes, and this is the agent's tasks, right? So so it has its own nodes and tasks to keep track of the work that it performs. And then you have 41 sources here. Now we also show the sources because it's very important, because there could be, for example, one of the documents I showed you, right, there was a lot of noise, so we need to show the user the sources. And this is the list for 41 sources. Now what I want to do, 4123 is actually the PDF ID, don't get confused on it. So essentially what I want to do is that I also, like in Perplexity, you get a chance to see the images, right? So the thing is, like, whatever visual content of the image the model reads, not the visual region, but then any image or figures that the model reads, I'm planning to show it on the right hand side somewhere here. So the user can actually click on the image and check it, because some of the image, like, you can't, for example, even in this doc we did see, in case the model was to reason through this, the user might need to see it. And not just that, but if you want to open this PDF, like, you want the user, we want to show this to the user at the end of the day. The model, our goal is to get a 100% accurate system, but also, as we did, I mean, we worked on a lot of personality assessment for like understanding what is their personality is about. So according to the analysis, they value, like they so they value, like, transparency over vagueness. So there is no, even if, like, there's a good chance, maybe 5% chance the agent might miss an information here and there. But the people who work here is actually using this as a supercharger, meaning that they are not depending on the answer. They want to rightly find it, and then they want to quickly verify it as well. So that source management is also something that you want to build properly, because it's not just about showing sources, but also showing, if you were to base a conclusion on what sources and what are the sources, you have to literally render the PDF on the UI, and then literally have like a UI where they can use the arrows and quickly skim through the sources. If not, what happens is that a lot of the other platforms, when you were to click on the sources, it'll take you to a PDF and then just give you boom, and you will only have the PDF. Or maybe they have used some sign text and highlight a certain paragraph. We don't want to do that. We basically want to build like a proper source controller. So they open up a model and they see a PDF, okay, this PDF, and quickly skim through the arrows, and they can see like a blue color icon, or like a UI, like a painting showing, this is the particular source is refer to come to this conclusion. So that's also something like a time saver sort of for them in a US bugs. This is like a UX UX thing, not a model or whatever complicated thing. And we also want to show all the images the model can come through. So this one and stuff like this graphs, because for example, like the model, for example, we're using Claude for chat, VLMs for document processing. Claude would actually get all of this right, but still, like, it's just it'll be nice if you can see something visually. Like, you ask something, you get a response, and then you see a lot of stuff visually, and you see the sources for it, and if you can check all the sources visually and text based, that's like, that would really give a good one. It'll build trust to the system. Second thing, it also help them out. Like, they might, when they visually see it, they might have become better follow, they might have get they would actually come up with better follow-up questions. They would actually come up with something else, like, okay, hey Claude, I checked this image, find me contradictions with this image, or whatever the formula, or whatever is depending on the documents and stuff like that. So literally they want to read documents as well, but then in the most efficient way using NLP here. So we would want to show this. Cool. So that is the progress we made so far. I've spent a little bit of very little time just explaining on the stuff, what we've done so far, and etc. And I also want to show it to you. I want to show you quickly. All right. Now I want you to run this in a sub agent. Yeah. Spawn a sub agent and run the same thing and do the research same thing. What I would do is that, let me actually copy this, refresh. I would encourage you to use a sub agent for this task. So this also, the model can actually spawn a sub-agent. Sub-agent is basically it has tools, and the prompts are a little bit different. The context is a little bit different, but it has mostly all the tools, except it can't spawn sub-agents because it'll become a recursive loop afterwards. So you can see the research thread that is going on. And yeah, the model can do parallel research, all of the basic stuff, but it can basically it's like making a clone of itself, and you can launch 3 or 4 of them. But for this, we're blocking it to only do a single research, and then another single research if required, because context, I don't want the context to be overlapped with any other cases. But yeah, you can still, that's like a good way of doing it. We have it sequentially, we can do it parallelly if wanted. All right, so I think let this run. I Yeah, let this actually run. Okay, the sub agent has given the response and you're getting the final response here. And this model is Haiku, by the way. So you can see the level of work it does for the amount of, I mean, the size is low, but I think size of model is low, but you can see it's usually accurate than most other open source models. Mm. All right, so let's get into document processing. Now let me pull up the progress. I guess, yeah. So I didn't plan for anything, so I'm just gonna, bluntly get started. So yeah, 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 I have a VM connected. Actually, we had a bit of notes saved, so we'll pull the notes from the development plan. And yeah, it's over here. We had a few conversations with Claude and also um, Grok as well. But yeah, we check the Claude's conversation. Okay, so work on GPU, embedding models, quadrant, RAM, speed, latency, queues using VLLM, and etc. Okay, so this is what we're going to work on. Set up. Okay, we'll actually start from a scratch pad. Okay, guys. So, because I think I've missed a lot of stuff, so I'm going to start from the scratch pad, and start very simple here. And most of the time, it is quite simple. What we're going to do is that we're going to process 10,000 documents. Okay, 10,000. The number is 10,000 documents. Yeah. So we want to process 10,000 documents. And some important information here is that we are using VLLM to process these documents. Okay. So I will let Claude do a lot of research and come back on the technical stuff, on terms of what the version of the model is and etc. But it's simple. We're using 10,000 documents. We want to process 10,000 documents. That's the entire goal. Simple. You want to process 10,000 documents. That's it. But yeah, and then you have components. We're using a VLLM to process the documents. The model is Qwen 32B VL instruct version. Okay. And what else do we do? So you drop in a document. Let's go through a flow, right? We drop in a document. The doc that yeah, you drop in a document. It basically runs across. It passes. It loads the model, and it does the work. So model is going to be so. I would say actually we'll take a look at one of the conversations we have with Claude. So let's go up. So I'm using Qwen 32B. If you have, okay, so basically I asked was like, we're using Qwen 32 billion parameter version, and but I'll be actually changing this to the 32 billion parameter version because we can't afford 10 10 GPUs and etc. I only have one H100 through Azure using my startup credits. So yeah, so let's see. Actually, I think we should have had this conversation now because I forgot we talked about. Okay, we'll have a conversation with Claude, like a fresh conversation. Okay. Actually, what I should have done is that once I finish the document processing, I should have actually jumped into indexing and saving all the stuff on Current, and then I should have once everything is because I have the context of what I worked on. Now I'm actually lost, but it's okay. We built it up. But yeah, the goal is simple. We want to process 10,000 documents on a single H180 GB version. Let's actually run. I want to look at what we're doing in the document processing, so I could get a chance see I could get a I could get a visual understanding of what's really going on, what other stuff we do in a single document processing, in a single document process review. Yeah, so where is it? Okay, so we're going to ingest this one particular document called 4 dot, I showed it to you, it has a lot of tables, so I'm just going to ingest this. Yeah, so I can see over here, this is for a single, this is just for a single document process, and you can see we load the document, we run a bunch of stuff using the model. Now Dockling models, you can run this in you can run this on a GPU, it'll be much faster. The PDF pipelines to the base, these models are less than 2 GB, so not a big deal, but still running on a GPU will even speed it up. The layout detection for formulas, of course, we're just doing formula detection, but yeah, doesn't yet matter. We're still using a VLM for it. So yeah, oops, open router error. Cool, but I get a sense of what we're trying to do now. I can recall what we did. So essentially, what we're doing is that now I've spawned a Cloud code to do some analysis and give me the flow, entire flow visually, or maybe through text. What we need to do, we drop in a document. The initial step will be to process. There's a bunch of processes identifying figures, identifying tables, identifying formulas, and etc. All of them right now is sequential, like identifying those specific things sequential, and then chunking has to happen. And once you identify images, the image process itself is parallel. So, for example, if you find 150 images, the model should be able to the entire pipeline should be able to run the images to a model and then get the descriptions and then actually save it to give back to the chunks, and then all the final chunks will actually merge and you'll have the final JSON. So the chunks at the end would actually look something like this. Yeah, will actually look something like this. And you can see like very small chunks do exist because we don't have a maximum number of chunks, or a minimum. We have a 250 chunk minimum. This is just to save the chunks in a very natural space, because dockling would actually give you an accurate representation of each paragraphs. So we are not having any overlaps, but yeah, uh, it's not a big deal, to be honest. So this is how it would look like, and you have images. Images are basically descriptions of the images, and then using the location of that. Let's say, for example, if you see this, let's go to this, right. Other the figure is a solid back, blah blah blah. BB, you call it BB box, bounding boxes. This is essentially mere locations, which you would actually uh, use to use a location, get back, and render the PDF or whatever. This is useful for seeing the visual regions and etc. Okay, so yeah, that's it. And then and you have formulas, tables in markdowns and etc. If it's a complex table, you have a description along with the BB box image. And this is one graph over here. These are visual figures. And you also have formula. And here you can see this is the entire equation, the lattice of it, and you also have a description because that's how we search the formula. Simple. Cool, cool, cool. Yeah. So here's the analysis of progress pipeline models used Qwen for what is this used for? Embeddings 104. This is for generating embeddings. Instruct for table form listing, Quentry re-ranker for re-ranking. Let's forget about it for now. That's re-ranking, like agent to retrieval part, not an issue. Dockling, large, and yeah. So content extraction, two parallel workers, symbol extraction and report extraction, document passing sequential, and then document passing conversion, phase tree content extraction, three parallel workers, tables, formulas, pictures, everything is parallel here. And VLM processing, maximum 4 parallel workers, open router. We're using open router. We're going to switch back to VLM. And yes, what else? And you have chunking output, building chunks, the final chunks, and then the embedding is saved, and you have the vector strip. Key bottlenecks. Yeah, dockling passing is sequential. We'll change this. All of this will be changed. Estimated for 10K docs. Sequential max workers 4 to 15 hours. So this is the idea. So basically we are going to be using I have access to a single H100, the 80 GB version. Version. I would also process each document parallel. For example, I would like to run at least 10 to 20 documents parallelly. And you would also need to know that we run each, like inside each document, we have things going on parallelly as well. For example, like images and etc. And I would say at this stage, the maximum tokens that you probably can think of is actually for a single request will not be more than 10,000 tokens. Maybe even less than, yeah, the we can just assume the maximum number of tokens needed for request is 10,000, because we even some of the times we process images and the images are in full quality, and even if they're in 1080p it'll probably be around 2,000 or 3,000 tokens. So do me a quick math and then come up with a yeah, come up with the optimal point. The thing is, we can add you need to take care of just not with the GPU RAM, but also the VRAM, the CPU, and etc. But I can use Azure to render the H100. That would be more than enough. So do like a proper math and then come back. What could be the efficient spot that we can process documents parallelly, like 10 to 20 or whatever the documents parallelly, and each of the document will have parallel stuff as well, like image processing being stick to one single document that is parallel and etc. So, do accurately, model this out and then come back to me with a solution. So we actually discussed all of this using Claude, but still, I totally forgot, the entire conversation itself, but we were able to do about 20 requests or something parallelly, but then we'll do it through Claude Code because it knows all the bottlenecks of the code and it has access to the entire code. Yeah. So cool. Let's go through them. Hardware assumptions. You have 48 to 96 cores. The system RAM is about 252. Let's assume 256. Is the number. High bandwidth, 2 quadrant. Uh, yeah. Let's do quadrant also through Docker in the same VM. Everything local. Models to run locally on H100. You have the 2.5 VL 32B version. Actually it's the 3 version, not VL 3 VL 32 something, but still it's 32, right? It's okay. Int 4 for VLMs for tables and pictures. VRAM 80 GB. Embedding model, generate embeddings, we have this. System CUDA overhead, we have 5 GB. Available for KB cache, 52 GB of concurrent inference. Okay, so with KV critical for concurrency, with 10K context, we have two number layers by KV cache dimensions context. So 2 by 64, 512, which is the dimension for, I guess it's for KV cache, and then you have 10,000 context length. by 2 bytes, you like 1.6 GB per concurrent request. This is also, I guess, this is for 10,000, yeah, 10,000 context. And maximum VLM request you can make within H100 is actually 32 requests. No, I'm not sure if it's 32 sequentially parallel, so let's check it out. Current parallelization calculation, current pipeline per document, a phase 1 context, 2 threads, GPU no, 2 seconds, phase 2 dockling, GPU no, yeah, for dockling I don't think we need a GPU, but yeah, we can run it through a GPU if wanted. Phase 3 extraction, 3 threads, no GPU. Phase 4 is VLM, because for dockling, getting paragraphs and stuff, you don't need the VLM. You're not using Qwen or anything for that. That's all dockling models, and that could fit in a basic RAM. Phase 4, we have 4 workers. And then the thing is like this, what you can do is that even though dockling is worth consuming 2 GB of RAM, right? We can save that 2 GB and do one extra request on a GPU, and use that 2 GB or whatever and put that into RAM. It'll just give us maximum, like 5-10 second boost. That's it. And maybe even less. um Current pipeline is this. VLM 30 seconds. Chunking one is sequential. Okay, VLM is a bottleneck. Each doc wants 4 concurrent VLM calls. Finding the sweet spot. Documents in parallel. Max VLM workers per doc. If you process 20 docs parallelly, VLM workers 4 for each. Total VLM request 80. It exceeds 32. If you were to process 16, you have 2 by 32, and it gives you an exact fit of 32 requests. But still, this is also a bit scary, because if something, if you'll still have a hop in the memory, and you might not sure, because uh, the thing is, no, I guess we can handle this 16 docs parallelly, because I'm assuming you'll have 10,000, but in general, images would only take 2,000, 3,000. So yeah. And documents in parallel 15, safe margin, exact fit is 8. And you do 8 docs, 4 VLM workers parallelly. So option A, balanced. Documents in parallel 15, VLM workers per doc 2. Total current 90% utilization. Yeah, this looks good. Fewer docs, more VLM per doc. Documents in parallel 10, VLM this thing, maximum. So CPU and stuff, you have 15 docs into 6 threads peak, 90 threads, 95%, but it's okay. Yeah, but okay, that's the thing. You can still fit it. 43 CPUs and 90, it could handle 90 threads. And then you have 10 docks, 6 threads, 60 threads, 60 comfortable. But I think we'll go with 15, 6 threads. RAM load, you have dockling 150 MB, 15 docks 2 GB, then it's RAM is 3 GB. But this can, with 250 MB, this is nothing. Like I would say, like peanuts. Throughout response, per document timeline for 2 VLM workers. So phase 1 you have 2 seconds, phase 2 you have 15 seconds, phase 3 5 seconds, 45 seconds of VLAN bottleneck, total 72, total 72 seconds per document, throughout with 15 docs parallel, effective throughout. Actually, I would like to stick with the 32 billion version, because It gives a good accuracy, and accuracy is far important here. And also one more point, give me more information about embedding batch space. And also most importantly, I guess the current code, it processes all the images at once. As far as I can see, like I think for if it detects 150 images or 40 images, it calls the API to process 40 images at once. Did you check it? I guess if that's the case, we probably have to think about it, and it should probably be so it can't process all the images at once. That's the thing, because each image would be in we are capping it at, we are assuming that each request will be 10,000, and image processing request will also be under 10,000, but in fact it will only be like less than 5,000, to be honest, if it's like one or two image. If you do want to do the calculation on the context, to be honest, because I don't think we are even so the maximum number of images I think is not even more than two. I guess it's two, and usually it's only one. So you need to do some math on that. And yeah, but your optimal configuration looks good. Just give me an info on these points. Let it do. Let me grab something. The good news, I found the answer. William process already one image per call. So hmm, yeah, it's well under 10K. Yes, thing is, I don't want to do any dynamic stuff and mess up the GPU, and something goes wrong. Actually, we could use VLLM to dynamically. For example, if you want to allocate 10K, the GPU will actually eventually have 10K that's allocated for it. But if you were to use VLM, what you can do is that you can do dynamic allocation, where if it only needs 2,000, you only use 2,000, and the rest of it is actually it's freed up. You have That's the most efficient way to do it. But first of all, let's solve this first, and then we'll work on VLLM if you want to do any dynamic allocations. And but it'll only save us, I would say, like 2 hours, because we anyway need to run it for 13 to 14 hours, and it'll do all the processing. And then you only have to keep this, you'll only save like 2 hours from maybe VLM. um yeah, but the thing is, like, we are already maxing out the system in terms of processing. We nearly, for example, in RAM, in general RAM, we are using it about 90 to 95%. In terms of, no, not the RAM, but the cores, we're using going at more than 90% and less than 100%. We're finding that in a efficient spot there. And then I guess overall that is like a good spot. 2 hours would make a big difference, wouldn't make a big difference for the work we do. um That is okay. So here, how VLLM token math this works. Ollama call API runs as an array of text, returns embeddings, currently batches to API call. For H100 with local Ollama, you need 600 conservative, equal to 64 for 80 GB, good balance. 128 recommended for H1, which H1 will be 8 GB VRAM, 18 GB used by VLLM. You have plenty of room to increase 128. No, the thing is like this. 18 GB used by VLM, right? Now the thing is we're limited on the number of tasks we can run with the cores and etc. Uh, and I also don't understand how is that only 18 GB used. Yeah, images around 5K tokens, not 10K, right? So we can allocate this. So 20 docs right now. So 900 to 1000 docs. We'll easily get 900 to the one image per API call. Yeah, but the thing is, eventually all the images and everything will be processed by VLM. You understand this, right? So no API calls whatsoever. Everything will be using in VLM. And I'm also curious to know how did you get this 18 GB number for VLM? So we have, if it's only 80 GB used in GPU memory for VLM, then we literally have 60 GB. Why not we use it? Like I don't seem to get it. I'm quite dumb. Can you just quickly explain me what's really going on in a concise way? Don't give me an essay. Because yeah, I know, I understand it's like a compute environment, compute thing, because you want to process each task sequence like parallelly, but then also max out with the number of cores as well. But we got eight, if we literally have got like, I don't know, 80 GB something like 8, 60, 40, 50 GB of excess model space. Model weights loaded once you sit there, remaining 60 KV cache for, oh, of course, yeah. That's what you're asking. Each request generates tokens. Yeah, that's what I wanted. Because I was like 18 GB for like what? Son of. So you could even do 25 docs into 3 workers, 75 still fits. Or 20 docs into 4, pushing to the limit. Yeah, parallelism budget. Yeah, I understand. Yeah, this makes sense. So what's the final numbers? Let me quickly go to portal.azure.com. Call it Meridian document processing. Deploy to, yeah, US availability zone. This is okay. Self-select the zone 1 stuff. Okay. Trusted one. Now I would like you to save the final details with any information or context to a single file. Feel free to visually put them in tables, so whatever is above, the numbers looks good. For now, let's stick to 25 docs by 3. Okay. It's a standard NCS. Okay. NC fort is ADS. Okay. Let's search that up and create it. Because I want to check if I do have quota for it. Maybe they remove it or something. I don't know. Oops. Oh, I think it's because of zones. West. Yeah. Like here, zone or latency doesn't matter for me much here, so I don't really care about it. Basic level of security is enough in case I want to install drivers. Oops, it's not available. Oh God, I don't have access to the H100. Or maybe is it because of Bangalore or Singapore? Asia. US Central. Okay, I think we can afford it, but the sizes are not available. So we'll just do zone 2. Yeah, okay. Still, I can't support it because insufficient quota. 40 vSUBUSes are needed for this configuration, but only vSUBUs of 0 remain for the standard NCDs family CPUs. Okay, do we have blocked? Oh, shit. What shall we do? I have one model inference which already has an H100. So I think I'll use that. Just stop some of the services. It's a bummer, but yeah. Let's check H100 pricing here. XSM is good. In case if I were to rent it for how many hours? On demand is 2.9, let's just assume in 3. 24 hours actually costs 720. No, we'll actually use my model inference. I'm going to, yeah. Uh, cool. No, we don't need this for now. First of all, I'll just quickly connect to it with my password. All right. The thing is, oh, okay, the thing, we have another issue. All about 10,000 documents are processed in a single VM. It exists in a single VM. Maybe, okay, maybe, yeah, maybe. What I can do is because I have a like a shared drive, right? So maybe I can attach this to this or something like that. So I'll explain this innovation solution to Claude. All right, so now I have created a. All right, so here's the scenario. I processed 10,000 documents and I've saved it in a different VM, in Azure itself. And it has access, and it has an external drive, additional data source or drive or something like that, I think. And I've processed 10K, not sure where, but yeah, 10K documents in it's in the VM. And I already have a VM which has GPU attached to it, but of course it's a different VM, right? I don't have no. 2 minutes. Okay. So what we need to do is that I totally forgot what I was saying. Yeah, so what I need to do is that I wanted to I want to know whether we could see what drive it is it and probably attach the drive or whatever the disk to this new VM as well. Or I mean, it's not the new VM; it's actually the VM that has a GPU attached to it and was created very long time ago. But I think it should be viable. Should compact the conversation and yeah. Yeah, but yeah, I think we can do it. We just need to attach attach the disk to this, and yeah, it should be good. I think you can do it because I'm not an expert in cloud and etc. I didn't do. I used to work with AWS, not and mostly GCP and AWS, not Azure at all. So I have some star grades for this, so I'm just trying to use this as much as possible. Two minutes, Varun. No, it's actually not about the current PDFs. This is different code, and the processing is in a different code. Oh, actually, what I'll do, I'll come back in a bit, and we have the code that's something different. Actually, we have a different folder for it, so we need to pull that folder, and we have to access that. Yeah, that's the general folder, and then you would use that specific folder to come up with the images and etc. All right, be right back, guys. All right, guys. Yeah. So sorry. Have There was a lot of background noise here and there, so I have to, kind of mute. But yeah, so we are able to. What we did was that, quickly, I didn't give you guys context on it. So initially, what I did, I actually had, I have the model inference. I didn't have quota for it, so I thought I can create like a attach a GPU for the VM that has all of the NASA docs, but didn't. So what I did was that I already I've created like a couple of months ago. I created a VM that has access to a single H100. So it's already attached to VM. I don't want to spend. I checked it at one part probably like 720 to $800 a day if I want to rent it. So I wanted to do it with my current VM. Uh, so yeah, that's what I'm saying. Did I So there was two VMs. One had access to the GPU, but not the NASA 10K docs. One had access to the 10K docs. So what I did was that I already I had 1 TB data disk attached to the NASA NTRS VM. I unmounted that, detached that, and basically attached this and mounted it to the GPU VM. Um, so yeah, and right now we have 10,414 docs moved to the VM with the GPU. Plus, we also have, just for the security, we also have a snapshot created in case something goes wrong. We also have, because I don't want to run the uh, the PDF download API for the next 7 hours or so. So I just create a snapshot and we have it here. All right, guys. So we do have it. I want to verify. Yeah, I want to verify the H100 as well. Yeah, actually, there is no, I don't think I install any drivers to it. So I don't think NVIDIA SMI will actually work. Uh, oh, no, actually, I did install drivers, I think, then. Yeah, then you can see the amount of RAM we have. Uh, yeah, it's 95G. What, really, 95G? I thought it was actually 85, not 95. It's the NVL. Okay, we have 96 GB. Wow. Then we have additional, I was like assuming it was 80 GB or something like that. Cool. Then this changes a lot, which means that we have additional 16 GB. So cool. Actually, I'll go back and say it's fine. I figured this out. Make sure to go through this entire H100 configuration. Now I just checked the amount of RAM we have. It seems like we have 96 GB of RAM. And I would also need to check what are the like basic system configs, like the hard disk, the storage, the amount of cores, the amount of RAM, the amount of CPU, whatever, all of those info as well. So yeah, how many cores do we have? We should be using, okay, 96 core. Yeah, RAM, all the disk drives. Cool. Sharing you more info about the system as well. Now, I'm sure this would change a lot of the things in a good way. So I want you to don't make changes to the document. Let's go through this. What does this unlock for us? Because right now we were assuming it was 80 GB and we wanted to do it. So we have additional 16 GB, meaning we can at least do another 5 extra document entire processing, or maybe even add extra workers or VLM workers for it. So let's see what we can do. What you actually have versus GB. Yeah, slightly less to be honest. We only have 4 cores, CPU cores. System RAM T14, good. Data disk, plenty. The big win is 16 GB VRAM. What this unlocks? More concurrent VLLM requests. Original math was with 80 GB, you could do 71 requests. Now you 96, you could do actually 91. Now you can safely run 30 documents, 3 workers, and 90 corners instead of 2. Yeah. With parallel documents instead of 25, 20% more throughout. And 10K toxins. Yeah, 6.5 hours, which is very good, which is a very good number. And in case we're actually using a lot of VLM as well, which is also a very good number. So alternative, and if you were to use a 7 billion version, if you were to find the 7 billion version that can, and here this for rocket stuff you need a lot of accuracy, but if you were to have like a minimum accuracy, you want to do it in a 7 billion version, you can still do it, right? Like this is you could, how much could it unlock if you were to easily triple the amount of requests? So you probably could do like 100 documents, in a single moment with a lot of the with the max number of workers and etc. um yeah. An alternative better code, instead of uh, you could you could run this quantized VLM. The thing is, I'm actually focusing more on the accuracy than the what do you call, I'm focusing more on the accuracy rather than the like time spent or something like that, because I think here we can afford for it. We need to afford, and we need to get the accuracy right, so there is no question to use a less uh no, I think in terms of I just saw quantization. Maybe we should actually use um like I think the bet using floating point would be better, right? In terms of accuracy, could we do FP8? And I think the model we are going to be using, open router Qwen model. Guess this is the one. So we're going to use that through Ollama then. Yeah, exactly. That's what we want to use FP8. Yeah, we might have a good, even a better accuracy one, because you can see we use this model from which is actually used, which actually by default, I think, I don't know what the deployment status for it. They've not shared any information whether they've used what quantized version or whatever in Ollama, sorry, on Open Router. But I think um, for Ollama, I can see by default this most of the processing, or maybe the inference you use would probably be a very less quantized version, and probably like for open source model probably on like a 5090 something. Not sure, you can't be sure of it. So, but here we can actually be sure of it because we are the guys doing it. And I'm actually thinking, look, I'm gonna use this model. I would like to use this model, but it's the same parameter count. Hmm. Yeah, FP8 preserves this thing, so available for KV cache, GB concurrent 72 requests. Yeah, 24. Yeah, in this case we are gonna, so we decided to do int8. Right now we're doing floating point, so still so int8 now FP8. So you have an accuracy bump, and you'll only drop like you're still doing we have still, so the extra 16 people are probably going to use it for FP8 instead of int8. Documents in parallel 24, VLM loaders 3, total concurrent junction, embedding batches 120 throughout in 8 hours. You can get it slightly lower than 884, but accuracy given tables is worth it. You only ingest once, better to spend an extra hour and get it right. Exactly. Want me to update the config table? Mhm. Please go through the Ollama page and give me any additional information you have. I'm curious to know, can we do FP8 through Ollama? Ollama is simple. I would, in a production use case, I'll probably go with VLLM. But yeah, this is enough, like more than enough at this situation. If not, if it doesn't provide, then we'll probably have to just go with um, the general numbers, but it's still okay. Later we can switch it up to VWare, like pull it from Hugging Face and do all of the custom configs and etc. If not, I think we'll go with, yeah. If not Ollama, then it's VLLM or directly through Hugging Face. The thing is, we need to have exposed OpenAI API. I need to be able to expose it as an API. For whatever reasons, or maybe we just don't need it at all. We just start up the server once the process is done, and we'll just kick it off from there. Ollama does not support FP8. Ollama uses GUF format, which has to consider as options, not FP8. Considerization F is better, very good. Options, option 1, Ollama Q8 recommend for simplicity. Size weight. Very close to FP16, better than Int8 than other frameworks. Yeah, this is okay, I would say. Concurrent request is 70, and this changes things a little bit, I would say. And I'm sure VLM, no, yeah, of course, for sure. Native H100 support. I guess we'll go with VLM. We'll spend some time on VLM. If for some reason, if it's complicated, we'll jump back to Ollama. It's actually good. Yeah, the difference between Q8 concept and F16 is usually negligible. Oh, then when usually negligible for FP16, then we'll just go with Q8. Then I think this is good. Yeah, we'll go with the second one because yeah, because if the difference in performance or precision is actually in difference, if it's usually negligible between FP16 itself, then I guess the best we just go with Q8. What's your preference? You could be Llama or use OLM? Let's go with VLM and see what happens. Yeah, I think we should. If you were to use the first, no, if you were to use this, how many what does it change in our request? Like how many documents would we process? Would it be the same? I think yes. Good choice. The numbers are near identical since VL has 32 parameters, same as ballpark. Recalculated for Qwen. 72. Yeah, nearly the same. You can do 24. Concurrency since parameters are similar. Model. Should we use VLLM? Let's go with this. Yeah, let's go with this option one. And yeah, update the docs. The thing is, in the past, I've spent hours debugging packages issues and all of these system issues using VLM. That's what I am VLLM. So that's what I'm thinking. If I have to do VLLM, or like if I were to hit a lot of the package issues and driver issues, I'm probably dead. I don't want to spend time in that crap, to be honest. And of course, we're using um yeah, I would also want you to add it as a note or something in case if we were to come back and integrate um the quantized version 8 of Ollama. This option. Because I'm sure if in case if we were to hit any issues or roadblocks with VLLM, we probably want to quickly fall back to Ollama and just quickly complete the document processing. It's actually like a last sort of resort, but just adding it there because in the past we've probably faced a lot of issues with VLM VLLM, and I don't want to spend hours debugging all those package and runtime issues. Yeah, exactly. CUDA conflicts. Yeah. Yeah, exactly. Yeah, this is what we'll do in case we both hit any roadblock with VLM. But I want to give it a shot with the VLM. Get that solved out. So I think what next is um, we would need to think we can start with the processing. So would you need to update? So how would we do it? So for example, what we really want is that we basically wanna clone this code, make it into a package or something like that, and just sort of run it. And yeah, apart from that, I'll be like, now before I deploy this code um, to the VLM, would you need to update any parts of the code? And also, I would say you would need to, yeah. So mm, I would say there's the hell a lot of work. I would say before there's a lot. Yeah. Now, would you need to update any parts of the code? Because I probably need a folder that I guess we already have a folder, but I would probably need to yeah, I would probably need to specify the of the directory of the 10K docs, and I want the pipeline to start, and it should do all the processing and all of those. And you should also know that we probably need quadrant and all of these embedding models, everything downloaded before it. So there's an initial installation step, and then is once we verify all of the installation sort of works, is when we actually start the document processing. So there's a hell of a lot of work here. I would want you to check the code and come up with a plan on how should we really deploy it, because this is a VM which will not have access to the entire code. I only need the code that could take in the directory of docs, and then of course have use Docker for quadrant probably, because we need Docker to keep quadrant over there locally on the VM itself. I mean the VM actually, and yeah, um, give me and a way for me to check, what is the update, what's currently happening, and a real time way to really see the concurrent stuff and all of those stuff. Yeah. So a ton of work. Yeah, I would want you to spend some time and give me a plan or sort of an approach for this. Because see, guys, you have a couple of models. One is embedding. You will also have the embedding models. I think we'll actually run it through VLM as well because we're using it. And we have embedding models, we have quadrant, we have processing, and etc. So yeah, we need to get the deployment stuff pretty good, and we don't need any packages. We just need Docker for quadrant and any Docker whatever you need, and then you need the embedding pipeline and just saving the stuff to quadrant. That's it. And we'll just process like a single PDF and see if everything is going on. If everything is working well with all the real-time stuff, again taking it simple for now, and then we'll give the 10K and docs, and yeah, yeah, and we should be able to see everything real time and give it a few hours and then come back after, I don't know, 8 9 hours probably, like next stream we should have the quadrant ready, or maybe even after a couple of documents you'll have the quadrant ready, which you can use it to expose as that as an API and start connecting this to the agent. Yeah, for now we'll just it's okay for now using Ollama to run this. We'll run the embeddings in VLM later, not an issue. Quadrant ingestion pipeline 10K docs, system packages, update everything, install Python, install Docker, install this, create project directory, mm, create working directories. Yeah, I'll just drag and drop the repo. That's it. Yeah. Oh, yeah. So this is a good plan. Update the config for H100 and verification step. Yeah, we'll copy and paste this code. This is a very good, nice job. So Ollama, all of this is so we want to copy and paste this code. Very simple stuff. So what I would say is that mm, just a few things. I would like to, for now, also because we're using VLLM, I would used to like to use the embeddings via VLLM as well. We can keep it at the native, whatever the config we're using with Ollama, we'll just use it. We can use it for VLLM. Also, I think I can see a lot of the code. You've given me a lot of code. What you can do is that create a folder and put in just c- yeah, instead of giving me as a text, just put those codes uh to the folder, because I can just like copy and paste the folder to the to the VM. And yeah, how do I rewrite a legacy calculation without? Hi Binem, I don't understand your question. What do you mean, how do you rewrite a legacy calculation without destroying the base? What do you mean? Because just give me info. I'm not able to understand your query. Do you mean to your system or this current system? I guess you can check our current requirements. We've been trying to run mostly like try to run latest packages for most of the yeah, try to use latest packages as much as possible. Maybe we just put, keep those at latest packages, and we hit an error, we'll come back and find an optimal package. Yeah. Right. So I think we're in good shape. We already have most of the files we want to do. Uh, let's quickly run through the gist of what we're gonna do next, and then going for a quick break for the lunch. Come back in a few. Create a deploy folder for all scripts. Quick start guide. Minimal dependencies. Start Ollama and VLLM. You run the checks and etc. To deploy to the VM, copy the folder. Mirror the end. Cool. We've pretty much got everything. Cool. So the next step is that we'll get this deployed, get all the services and process one document and see if everything works well. Then we'll, run a few hundreds, and if that works well, we'll just dump it for 10K and just leave it for the day. Come back tomorrow and then check how the processing went as well. Now, we would also need to take care of a lot of the quadrant load and etc. But I think quadrant, like, out of the box, I don't think we need to do any efficiency gains, because I think quadrant, it provides most of the efficiency stuff, so we don't need to really think about that. But I think this is okay for now. So I'm gonna take a quick 20 minutes break, come back after lunch. All right. Alrighty. All right, so we're copying all the folders and the files. Done. Quickly run this. Put this command to a file and I'll copy it from there. Because you have this weird line breaks when you were to copy this from a terminal and all right, password. We have the source file with all of this. Good. What else is left? Okay, I guess requirements will also be saved. All right. Cool. We have the requirements, we have the meridian, we have everything done here. Okay. So our GPU instance, we have the deploy command, we have the source, we have the embeddings, we have the pipeline, we have the extractors, we have everything. Cool. So just to I want to test. Yeah. First of all, I guess the next step is installing all the stuff. But the end goal of it is that I want the pipeline, everything to work for a single document. And once we correct, once we, or maybe like the first 10 documents or something, once we um, confirm that everything that we've done is working for the first 10 documents, then we'll actually jump into the next 100 or maybe the entire 10K. So what's the next step? The code is on the VM. Here's the installation sequence. See Meridian, we're already in Meridian. No, but we had a different process for it, right? Like we wanted to install all the packages and etc. Like the thing is, I want like what I meant when I mentioned I want to process the one document is that I want to first of all get the thing is like this. It's confusing. Actually, go back. No, actually, when I meant I want to process a file, I wanted to mention that, we want to go through the entire setup. Like our deployment setup is very different, right? Like I want the monitoring, everything. Just assuming we'll do it for 10,000 documents, but for now we only want to at the end process one document. But we want to do everything in terms of whatever we've planned to verify setup, the ingestion, the start services, everything related to the H100, just to check. I mean, we just gonna assume we're gonna do it for 10K, and we do everything possibly as possible, accurate as possible, and we only process one at the end just to see whether the entire pipeline is working. That's what I meant, because this seems like just sort of like quickly trying to manually verifying that to run a model or something. This is not what I want. We planned it pretty well before. And we have the deployment guide and ingestion config as well. So we just want to take it step first. We do everything whatever, like if, as we plan, and then we move forward. This is one we're going to do. So we update everything. So what is created? I think a bit of directories. Can I follow the deployment guide? Can I just copy the first 1.1 and just paste it? Do you want me to follow your commands or just copy paste things from the deployment guide? So yeah, we are just updating all the system packages. create project directory. Also, like I says before, we plan to do the Ollama embedding model with VLM as well. So instead of Ollama was the last choice. I guess we updated, we talked about it in the middle because we are already using VLLM. We'll use the embedding models also to VLLM. Is that possible? And I also for the VLLM, I would say, sorry, for the embedding model, we can just load it at int8 or fp8 or q8-0, whatever, doesn't matter. Or we can just keep the same q8-0 sort of config with VLLM. Is that possible? Actually, it's fine for now. Let's just stick to the plan. We'll use Ollama for embedding model later. Let's just change stuff. It's fine. I think in terms of VRAM usage, it'll be the same, right? Ollama is only loading that model, and VLM would only also load the model. So in terms of RAM usage or VRAM usage, it'll be the same, right? That's because that's what I care about. Doesn't matter Ollama or VLM. Essentially the same model weights and the same size regardless of the serving framework. Exactly. Oh, okay. Okay, the thing is in that mod in the same VM I've actually been running Ollama. And I think I have like I already have two screens created. So what I want to do is to scrap all the screens that I have and also kill the Ollama instance, and then I can run the 2.2. Okay, install the latest one. Sure. The thing is, I force-killed Ollama's prior process, and once I complete the installation and do Ollama serve, actually once I complete installation, is actually serving, I guess, starting the API. See the logs? Pull the model. Okay, we have the Qwen B version. So I was running, this is the prior model I was running 20B version. I've stopped it, running this. The model has to be loaded with shards and all. First time would actually, when you run this first, it will take some time. Afterwards, it should be quick. Yeah, without delay, we'll go for the next one. Here. Okay, we got the embeddings. It's working. Okay. So it's loading the model. As usual, just one error. Ran this command, I guess the model loaded and I got an error. Now because it's we've installed that, we've run that in a screen, I'm not able to scroll up or scroll down. Give me a command so I can copy, the whatever the characters you want to see what the issue is or what the error is. Now, for now, I don't need any screens because I just want to test stuff and get the logs and be able to see it. Because I'm not gonna close a VM now. Later, we'll use the tmux, but for now, we don't need screens. We'll just disable the screen, terminate the screen, and run it one more time. Control A and D to detach out. Because I'm not gonna run everything right now. Actually, I wouldn't want to waste any context, so I'll be like, what is the error? Just paste it. I don't want to leave this. Uh, I don't want to get into an auto comparison. Oh shit. Oh, hey, Juan CSA, just saw your message. Hi, hi, hi. Not sure if you messaged before or now. Yeah, I have a background in computer science. Yes, yeah, yeah, yeah. I did my degree in software engineering and computer science, and yeah, I couldn't I mean, yeah, nearly completed it, and yeah, background is CS, yeah, but mostly self-taught. Yeah, we've been looking for someone like me. Yeah, is Claude Code really all that? Yeah, yeah, literally. Yeah, for sure. For example, so the project, this is day seven, and I'm building a rack system. I'll send you the link of what we're building. This is what we're trying to solve. Maybe it's in the description of the video. Check the description of share the description of the YouTube video. But basically, this is such a complex system. Not super damn not rocket science, not rocket building like rockets. But then in terms of system level, it's very, at least with AI, this the stuff on the agents and the documents we work with. It's very complex, tend to take easily like 5 to 6 member teams who's working full time for like a few months to figure out all of this stuff, in terms of UI, in terms of experience, in terms of like documents, everything. Uh, Probably like a couple of months project, and easily like 200 300K sort of project value. um I'm just using Cloud Code in day seven. Right now, we've solved document processing to process tables and etc. For example, as you're jumping in right now, I'll quickly show you like a refreshment on the amount of content we work with. You can see these are like scanned copies from 1950s. And if I go over here, you can see the documents have a lot of formula and etc. So all of the extraction has to be accurate. It has to be 100% accurate. And yeah, quite complex documents. So we see this is from 1967, and they have a lot of tables. Do you see? And all of these are very sensitive information. I mean, I'm clarifying this, but yeah, since we the sensitive information in terms of a company, so we're using open source models to run this. So yeah, it's with Cloud Code, of course. Like I'm literally building something that takes 4 to 5 months. At minimum in like a couple of weeks, and just being a single member, and of course with all like 10x the amount of quality and stuff. So your question, but you still need the software dev, right? Is there no way I can do it in my own? No, the thing is like this. For example, for you to build something like what I'm right now building, you need to have some sort of computer science knowledge, because it's cloud. It's so much. It's it's not impossible. It can be done, but you need to have that fundamental software background, computer science background. And the tool, like for example, if you were to be a non-developer, you can use Cloud Code and all of this bunch of tools to create websites, to create like apps, and like fairly easy sort of applications. But if you want to build stuff like this scale, where it's quite complex in terms of like documents, in terms of agent, in terms of infrastructure, in terms of cloud and etc., it's definitely yeah. But the thing is, you can start, because a lot of things have changed. What you can do is that you learn the fundamentals of software engineering, and not software engineering, but in computer science, in terms of, I'm not saying theory, right? I'm not saying you to go ahead and really learn theory and about computer science and stuff like that. What I'm trying to say is that, and if you want to get into have a career, you want to do something in the software space, start now early, use build, just increase the complexity of the apps, so you'll have more needs. Because that's the one way you can do it. Like if you were to work with a very small website, work on a big one with a lot of features, where you need to have back end, front end, a ton of things happening, but increase your complexity and try to achieve that. And I did a similar project a while back. Are you using overlapping for processing bit? No, I'm not using overlap. I'm using Docklink. So this is an open source layout detection framework called Docklink. It's by IBM. They have a model for detecting like documents and stuff. But the thing is like this, I'm only using this for detection, and I'm using my custom pipelines, tables and transformers, etc. to do the stuff. In fact, in this case, we are processing 10,000 documents. So each, for example, just to show you, right now it's 10,000 documents we have at hand, and each document has about 50 pages. So yeah, about 500,000 pages. Yeah, 500,000 to 750,000 pages is what we are processing and saving in Quadrant and doing all the vector stuff. So overlapping for this, no, it's not a big decision. If you want, you can have overlapping. Um, yeah, so another question. Amount of data, it is a couple of pages. See if any data is related to answer key. going. Then look at the small chunks. Something like that. But the thing is like this. So we've spent about 30-40 hours on this, right? So I would encourage you to go back, watch some of the past live streams and see. I guess it was on the third one or the fourth one, I don't remember, but it's probably in the first three. So the first, second, third, there's three live streams. They part one, part two, part three. Watch all of them. It's quite long, but just skim through different parts, and we've been working on that. So I can't give you a definite answer on that because we've done a lot of things in terms of chunking. It's different for formulas, it's different for pages, it's different for graphs, figures, etc. Yeah. Awesome. Awesome. Yeah. Brother can't hear shit. But you can't hear me? Is my audio all right? I think so. Or at least the last time I checked, the audio was right. I think let me verify this. Let me quickly open YouTube and check if my audio is good. Quickly open YouTube and check if my audio. Yeah, of course. Audio is good. Feel free to drop in any questions. As I move on, I'll just take a look at them. I'll probably answer those. Okay, so again, error. No, I've got an error. The selected lines are the error. For example, sometimes Claude just space it like that. Oops. Like, why are we facing this issue? Can you search the web? Probably this was fixed, or or you can use context of an MCP to search through VLLM docs. Launch a sub agent and try to check on this. Launch a sub agent to verify VLLM docs and whatever the docs to try to see if there was a potentially proper viable fix. Use a sub agent. So I think the audio should be better now. I'm sorry about that. Yeah. Because whenever I join a Google Meet, it sort of it changes the audio volume and the output gain, and that's why I think there was you have seen a drop in the audio. This is one of the reasons I didn't want to use VLLM, because there's totally a different inflow of all of the dependent packages and all of the. So Ollama is quite easy. Just pull it, it manages everything. You get them all running in a few minutes, not even minutes, I would say less than a minute. VLLM is something that if you wanna get the juice out of the GPU and you have a lot of time to do so, is then when you use VLLM. I just wanted to try and show it to you guys, because trying to build, just showing you parts of it. In a real deployment, we'll probably use VLM or Ollama. Doesn't matter. Yeah, yeah, sure. Awesome, buddy. I'll accept. So will I could try option first, the first command, but I can see the number of workers and etc. A few of the thing. I can see some changes on limits and etc. But will this affect our plan of will this affect our plan of deployment? Meaning, like, we wanted to process 25-30 docs, right? Could we still handle this, or would this affect that? Because if not, I'll just be better off running Ollama. I should have simplified it. Actually, my bad. Mm. Why is this issue? Is it because of Ola? Is it a VLLM like package issue? Because we installed the latest one, right? Would installing the stable version still keep us on track with the concurrency rates? Just curious, what do you recommend? Wait, if VLM pip package is built for CUDA 12, then I'm sure VLLM SSH package or something on other bash download or whatever will actually give us support for CUDA 13, right? Are we only dependent on installing VLLM through pip, or is there any other way of installing it to have a version match with CUDA 13 support? It's stupid decision. That's why you can't trust these models. Another workaround is to just install it via SSH or something. Yeah, idiots. The official VRAM containers for newer CUDA. This guy NVIDIA provides it, but just because I just mentioned we'll do it for pip and it didn't give me any information. Yes. That's why you can't run models for hours. It'll do everything correctly, but it'll miss on very, very small decision making points here and there, which will anyway fail the entire project. And you have to sit down and debug for hours. So instead of that, you can just write stuff yourself. So we'll install this first. Let's just give this a minute. I think I'll have to pause this stream in 5 to 10 minutes to head out. And once I come back, I will actually continue the stream. And yeah, I wanted to do it in a go, but yeah, to go out to the gym. So I'll come back and continue this. But yeah, I think this should work because usually it's a Docker whenever because Docker, you're running a Docker container with code that can support. Now most of the time it's Docker. As long as the build works for them, it'll most of the time work for us, and it's exposed through API. So we're not touching anything, just clean, just very clean approach. And we just start this Docker file. Yeah, and then it should work. Let's see. Yeah, you can do this as well. This is also, Yeah, this is also straightforward. Instead, if you don't want to use Docker and manage containers and etc., if you want to straight away do it in bare metal, where if you don't have Docker, clone the GitHub VLLM .git and do it. Actually, I forgot because I didn't do VLM for a while, and yeah, I was just testing a few things, messing with just Ollama because infra stuff. When I touch infra only, I didn't touch infra for like 2-3 months. So okay, I think we're just done. Yeah, yeah. So always, like Docker, like, very easy. Just one line of code, you just deploy it, and you don't need to write anything. Just copy paste it. Easy work. Just hopefully this should fix the issues and run the model. Oops. Docker GPU need to install NVIDIA container. Yeah, that's why this bare metal, just do the GitHub is fine. But yeah, we made some progress in this, so we'll just continue this. Oops. Oh my god, I actually closed Visual Studio Code by error. Okay, cool. I think, yeah, anyway, this is a good spot to stop. We've planned, so uh, we have a deployment guide set up. We actually following it, and we also have the H100 configuration, and this is what our injection pipeline would actually look like. Okay, so this is what we did for the 4 hours, I think, to 1 hour of solving errors and just unproductive stuff. But it's okay. You have to go through this. You can't leave it. Yeah, I'll come back and install the other service and keep the progress going. And let's see. I'll actually run this. Just a minute. I should run it. Can you, for God's sake, put this into a file temporarily so I can copy this because line breaking are causing them stupid issues. Yeah, we'll just copy it from here. Okay, so this is all installed. Okay, so this will run for a few minutes. Come back in a bit. Okay, then again, yeah. Click install transform. I think we need to install this laptop. So maybe this is working. Wait, this is not really good. You can't change models. Why are you changing models? Then will installing VLLM directly through Git will solve the problem. Like the direct Git VLM. Is that the most straightforward, proper approach of doing it? Mm. No, you idiot. Not through pip. I'm talking about directly from VLLM Git. Please do not code. Let's talk through this. Yeah, okay. So I think we'll try it. Wait, is it a single shot? If it doesn't work, we'll jump back to Ollama. Okay, I think, yeah, we're just hitting into roadblocks out of roadblocks. Can you just pause and just give me an idea? Assume I'm a dummy. What is really going on, and why we have CUDA 13? We are not using direct whip. Then why is it failing? What's the issue? Yeah, we'll use point 11.0 from whip. Let's go with option 3. Okay, we'll try one more time. We'll just downgrade the package, come back to a low version of VLLM, test it. If it doesn't work, then call it for the day and just simply work with Ollama and come back to like the improvement infra later. Because if I spend time like this, I'll only complete the project in, I don't know, another. Because see, the main parts you can easily build. The complex like form detection and everything, those are very easy in terms of like you need to spend a lot of time. You can be there's no a lot of blocks here. We like cognitively there's some blocks, but these are like basic errors. I don't even understand what the a ton of build packages and etc. Such a mess. Anyway, we'll just try this basic stuff. This should be very clear. Or just have one Docker where I can run and everything will work. Install all the packages because we just need the inference working. There's no one single Docker that I can sort of just put like quadrant. I just put Docker and it just magically works. Yeah, VLM should have Docker. I think if it has, that's great. Yeah, I've been thinking about doing this for my logs, notes, books, and forms I downloaded. Yeah, sure, a good project to try. Try and let me know how it goes. Alright guys, so I need to wrap this off. I'm just heading out. I'll come back in about 3 hours and then continue the stream. And yeah, we'll wrap this up. Try to wrap this up by today. And then tomorrow we'll connect the agent, solve all the problems we deal with. A lot of docs, but then the agent relate the problems. And yeah, spend a couple of this. And by end of Friday, my goal is to wrap this up. Okay. Alright guys, talk soon. Bye. And yeah, feel free to check out some other live streams and passings. I'll update the videos with good chapters and descriptions later on. Okay. Awesome. Talk soon. Bye. Yeah, man. Have a good day, you too, and hopefully, yeah, catch up soon. Follow me in LinkedIn if you. It's called it's the same. Just Google up Rasan Gobinath and give me a hit on LinkedIn. All right, talk soon. Bye.